So is the screen visible? Is my screen visible? Yes. Okay. So we completed till variable acceleration, right? We solved this sum now. We solved this sum yesterday.
Yes, sir.
Okay. So what is the answer for this?
56 meters, sir.
56 meter. Okay. So today, so we have completed non-uniform acceleration, that is variable acceleration. So today we'll see uniform acceleration. Okay. So a new topic. So what are the topics left? Okay, to complete motion one dimension or motion straight line. So you have uniform acceleration. Okay, and we have motion under gravity. So that topic is there, and we have relative velocity. Okay, and importantly we have distance traveled in nth second. So here we have like 4 topics left, okay, to cover. CBSE and NEET and JE portions also. Okay, today we'll try to complete uniform acceleration. Okay, so after that we'll have only 3 topics left. Okay, yes, so yeah. So we'll see uniform acceleration. So when a body is moving with uniform acceleration, okay, when a body or an object, okay, is moving in a straight line with uniform acceleration, okay, so how to describe this motion? So how to describe this motion? Okay, the motion of the object traveling with uniform acceleration. Okay, and it is analyzed by a set of equations. So that is nothing but you would have studied in your lower class also. That is equations of motion, right? Equations of motion. Okay. So the equations of motion. So first we'll elaborate the quantities first involved in the equations of motion. Consider a particle. Okay. Consider a particle moving. Okay. Consider a particle moving with uniform acceleration. Consider a particle moving with uniform acceleration. Okay. In a straight line. Just a moment. Welcome to the class, Disha. Good evening.
Good
So,
evening, sir.
yeah, so we have started uniform acceleration. Okay. So, so consider particle moving with uniform acceleration in a straight line. Okay, in a straight line. So the quantities involved are u. U is nothing but initial velocity. Initial velocity. And v. V is nothing but final velocity. And we have s. These are all meter per second, as you know. Final velocity is also meter per second. And s is nothing but distance traveled. Distance traveled in time t. Okay, it is in meters. Okay, it is in meter. Okay, so we have u, we have v, that is s is distance. Okay, and obviously you know that the next quantity we are going to see is time. So that is time taken. Okay, time taken by the particle or the object moving with uniform acceleration to change the velocity from u to v, to change from initial velocity to final velocity. So it is the time taken by the particle to change from the initial velocity to the final velocity. So that is measured in terms of seconds. Okay. And last but not the least, acceleration of the particle or the body. So it is, as you know, meter per second squared. Okay. So you know the set of equations of motion. Excuse me. So what are the three equations of motion? Three equations of motion. We have to elaborate this, these equations also. Okay. Sorry, we have to derive this equation so that it will be useful for us to, to inculcate shortcuts while solving NEET and J equations. Okay. So what are the three equations of motion? What is the first equation of motion?
V equal to U plus AT.
Very good. V is equal to U plus AT. V is equal to U plus AT. Very good. So you know the derivation of this? So derivation is acceleration. So acceleration is equal to nothing but change in velocity divided by time. Okay. So change in velocity is nothing but final velocity minus initial velocity divided by time. Okay. So v minus u by t is equal to a. So which becomes v minus u is equal to at. So this u goes to that side. So v is equal to u plus at. So this is a small derivation. And the second equation of motion is the second equation of motion. The second equation of motion, anybody? Yes.
S equal to so
S equal to
UT plus half AT square.
ut plus half at squared. Okay. So this is also an important equation, and you should know the derivation also, because we're going to apply this derivation, some parts of the derivation, okay, while solving the problem. So always remember, in uniform acceleration or in constant acceleration, okay, or in constant acceleration. Okay. So when a particle is moving in a straight line with uniform or constant acceleration, okay. So the average velocity, you know what is average velocity, right? What is the average velocity formula? Yes. What is average velocity formula?
Dx square by t.
Average velocity is not dx by dt, del x by dt. Am I right or not?
Yes, sir.
Okay. But when a body is moving with constant acceleration, the average velocity is nothing but addition of initial velocity plus final velocity divided by 2. That is the mean value. Mean value of initial and final velocity. So you understand this? So what is a formula for average velocity when the body is moving with constant acceleration? V plus u by 2. That is initial velocity plus final velocity, or final velocity plus initial velocity by 2. Okay. So you have to remember this. Okay. And yeah, and another formula, that is so what is distance? What is distance actually? In general way, what is distance? You know, that is distance by time is equal to what? Speed, right? Speed is equal to distance by time. So what is distance? Distance is equal to speed into time. Okay. So that's what we are going to see here. So what is distance? Distance is equal to s. S is equal to, what is the speed here? average velocity. Okay, when we are calculating constant acceleration, what we can calculate? We have only average velocity. So average velocity is what? You understand? V plus u by 2 into time. Time is what? Seconds. That is t. So you understand this? How this comes? S is equal to u plus v by 2 into t. You're clear, ma? You have any doubts? Are you able to understand this? Yes or no? Disha, Jayashri, do you understand this or not, ma? How we land up here? There's no response from you guys. See, speed is equal to what? Distance by time is equal to speed. Okay. So if I want to find out the distance, what I will do? I'll write here distance is equal to speed into time. Now, as we know, you're dealing with uniform acceleration. Okay, objects moving with uniform acceleration. So when I want to find the velocity, okay, when I want to find the velocity, okay, of the object, velocity of the object moving with uniform acceleration, okay, I can only find out the average velocity. Okay, average velocity, that is okay. So when the body is moving with uniform acceleration, the average velocity formula is nothing but initial velocity plus final velocity and the mean between them. Mean value of initial and final velocities. Okay. So now I want to find out the distance of the object moved. Okay. Distance the object moved, that the object which is having uniform acceleration. So what I have to do, I have to substitute distance. The place of distance I'm substituting s. The speed of in the place of speed I have velocity, that is average velocity. Okay, that is u plus v by 2, and in the place of time is same, so t. Okay, s is equal to u plus v by 2 into t. Okay, now you know what is v. What is v in the first equation? V is equal to u plus at, right? Substitute this value here. So s is equal to u plus at divided by 2 into t. So take this t inside. So what happens? So sorry, it becomes first it becomes, we can simplify as s is equal to u plus u becomes 2u plus at divided by 2 into t. Take this t inside, so it becomes 2ut plus a t squared divided by 2 is equal to what? Is equal to s. So which in turn, what happens here? What could happen here? Okay, so what could happen here? That is, we can write it like this: 2ut by 2 plus at squared by 2 is equal to s. So this 2 gets cancelled. So s is equal to ut plus half into at squared. Okay, so this is the derivation. So you're clear with this? Yeah. So you already know this. I'm just refreshing your memory so that you can easily solve sums. So the second equation of motion, you know. So here, you know what happens when a body moves with uniform velocity, you know? This is just a note. Just take it as a note, okay? When a body is moving with uniform velocity, what do you mean by uniform velocity? Nothing but constant velocity. So when a body is moving with uniform or constant velocity, you know how to find the distance. Always remember that uniform velocity will be equal to average velocity. So for example, if a body starts here at maybe 0 till 10 seconds, it is moving with a velocity of 30 meter per second. Okay, it started here, it ended here. Sorry, we are calculating, it's not ended here, so it is still moving, but we are calculating between the time interval 0 to 10 seconds. Okay, we are calculating the uh, you are calculating the motion between 0 to 10 seconds only. So the initial velocity is 30 and final velocity is 30. Okay, so what you can say is that it moves with a uniform velocity. Okay, it moves with uniform velocity. 0 to 10 seconds, it is moving with only 30 meter per second. As you know, it is uniform velocity. So you have to know here, between the 0 to 10 seconds, uniform velocity equals the average velocity. So you understand. So if I want to find out the velocity, so that is the distance can be written as average velocity into time. If the body is moving with uniform velocity, you can employ that value, that is uniform velocity value, in the place of average velocity. So what happens? S is equal to uniform velocity into time. Okay, so do you have any doubts till now? Please give me an answer so that I can proceed to the next one.
Yes, sir.
Okay. So yes, so what is the third equation of motion? What is the third equation of motion? V squared is equal to u squared
V
plus
square plus 2as.
2as. Okay, very good. So here what we have to do, first take the first equation, that is v is equal to u plus at. Okay, and to find out t, we can write like this: v minus u is equal to at, and v minus u by a becomes t. Okay, so likewise we can do. So in the distance equation, that is s is equal to ut plus half at squared. Okay, substitute this value of t here. So when you do that, s is equal to u into v minus u by a plus half into a into v minus u by a the whole squared. Okay, so here you can take this v minus u outside, so v minus u as a single common entity. Okay, u by a plus half into half into half into v minus u. Okay, v minus u by a. Okay, v minus u by a. So this will be it. Okay, so now it becomes like v minus u into u by a plus v minus u by 2a. Now this is yes. Okay, distance. So now take LCM. The LCM will come as 2a, so it becomes 2u, right? 2u plus v minus u into v minus u is equal to yes. So here 2u minus u becomes v plus u into v minus u, this term, divided by 2a is equal to yes. So a minus b, a plus b formula. So that is s is equal to b squared minus u squared by 2a. So take this 2a that side. So that becomes v squared minus u squared is equal to 2as. So v squared is equal to u squared plus 2as. Okay, so these are the derivations, and this part of the derivations you can use. Okay, I'll tell you, will this be helpful or not? I know you'll be wondering. Okay, but this will be very helpful. Okay, so we'll see in the sums. So when the acceleration is positive, that is plus a, we know the uniform, that is equations of motion as v is equal to u plus at, s is equal to ut plus half at squared, and v squared is equal to u squared plus 2as. What if the acceleration is negative? So employ this negative sign here in the place of acceleration. So it becomes v is equal to u minus at, s is equal to ut minus half at squared, and v squared is equal to u squared minus 2as. Okay, so these are the basic things. So we'll see the sums first. We'll go with NEET and JEE questions. Okay, yeah, this first question, it is asked in AIPMT, now NEET, All India Pre-Medical Test 2008. Okay, they're asking the particle moves in a straight line with constant acceleration. Okay, a particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meter per second while passing through a distance of 135 meter in t seconds. The value of t is, okay. So they are saying the particle is moving with constant acceleration, changes the velocity from 10 meter per second while passing through a distance of 135. Okay. So here they have given this is u, the initial velocity as 10 meter per second. Okay, and they have given distance also, passing through a distance of s is equal to 135 meters. Okay, and yes, and they are asking the value of t. Okay, so they are asking the value of t. So always remember, so when you come across this question, you should have that it is moving with constant acceleration. So that should be underlined. Okay, so whenever you come across this question, that constant acceleration should be underlined so that you can you know employ that formula. Okay, the one we have derived, no, so the derivations could be applied, not only the equations of motion but derivations can also be applied. Okay, so now, yeah, so now you can find out the first, I think you have to find the question complete. I don't know, actually the question is not completed, just a moment. See, it changes velocity from 10 meter per second, it has missed here, to 20 meter per second. Okay, a particle moves in a straight line with constant acceleration, changes its velocity from 10 meter per second to 20 meter per second. Okay, so they're given final velocity also. Final velocity is 20 meter per second. So now they're asking what is the value of t. So which can be employed first? Which equations of motion can be employed first? You just have to answer the question. Jay Shri Disha.
Sir,
Yeah.
b square minus u square equal to 2as, sir.
Yeah, very good. So because v is equal to u plus at cannot be employed because you don't know the acceleration formula. So now you have to find out what v squared is equal to u squared plus 2as. Okay. Now find out the acceleration. You have to find out first, you have to find out the value of a. When you find out the value of a, then you can employ that in the first equation, v is equal to u plus at, and you will get the value of t. So what is the answer? Come on, you can do this question.
Sir,
Yeah,
10 by 9, sir, acceleration.
very good. Acceleration is equal to what?
10 by 9.
10 by 9. So employ that in here in this equation. So you know v, you know you know acceleration, you don't know the time only. So you can find out the time.
Sir, 9 seconds, sir.
Very good. 9 is the correct answer. So you have, yeah, this is the normal way of doing it. Okay, but there is an easier way of doing it too. That's what I said. A particle moves in a straight line with constant acceleration. Okay, underline this word. And they have given that it changes from 10 to 20 meter per second. That is, you know, initial velocity, and you know final velocity, and you know the distance also. Now you have to find the time only. So the easiest possible acceleration to solve, that is like the easiest possible way to solve this question, because you know that you have only 1 minute, no, even in JE and NEET, to solve a question you just have 1 minute. So what is the distance formula? in constant acceleration. Average velocity into time. That is nothing but distance is equal to v plus u by 2 into t. Now s is equal to what? 135. V is 20, u is 10 divided by 2 into time. Sorry, 135 is in this position. 135 is equal to, okay. So what happens here? 135 is equal to 30 by 2. So it becomes 15t. 135 divided by 15 is equal to t. So t is equal to 9. So you get this? So why I said the derivation is important? You can directly find out the time without finding out the value of acceleration. You get it, Jayashree?
Yes, sir.
Okay, so this is the easiest way. If you know the derivation, it is very easy. Okay, so when they say you have that the body is moving with constant acceleration, you know the value of initial velocity and you know the value of final velocity, then you know the value of distance. Okay, then you can directly substitute this in the first derivative. This is the first step, right? First step in the second equation of motion derivation. Okay, so that we can do. Okay, so here a car moving at the speed of 40 km per hour can be stopped by applying brakes at least 2 meters. If the same car is moving at the speed of 80 km per hour, what is the minimum stopping distance? So what they are saying is a car is moving at the speed of 40 km per hour. So this is nothing but u, initial velocity. Can be stopped by applying brakes at least after 2 meter. If the car is this here, it is 40 kilo. If they apply a brake in 2 meters, okay, it comes to rest. That's what they're saying. So here the u is equal to 40 kilometer per hour. Here it has come to rest. So rest is nothing but v. The final velocity is equal to 0. So whenever it has come to rest, the final velocity is equal to 0. And the distance is nothing but 2 meter. Okay. And as they said, they're applying brakes. Applying brakes means what? Anyone? Applying brakes. When we apply a brake, what happens?
Sir, it came as zero condition.
Excuse me, ma?
It comes into zero, sir.
You mean the velocity?
Yes, sir.
Yeah, but okay, what acts? Something acts so that only that velocity is decreasing. What acts there when you apply a brake? What comes into effect? Always remember when you apply a brake, okay, even when you go in vehicles, retardation comes to effect. That is, the negative acceleration comes to effect. Okay, so that you have to know. So they are saying if they have given the situation here till here, they are saying if the same car is moving with the 80 km per hour, that is u is equal to 80 km per hour. What is the minimum stopping distance? The distance they are asking. Of course, they are saying the velocity, that is the final velocity will be 0. What will be the distance? So the common thing between these two is this for this car and this car is the same acceleration, or sorry, same retardation. Okay, same retardation value. Same retardation value. Okay, so this car has also the same retardation value like this car. Okay, this car has the same retardation value as this car. So you understand the question?
Yes, sir.
Okay, and the thing is, you could have easily solved this question if they are given this meter in kilometer format. Okay, if they give 2 meters in kilometer format, you could have easily done this question. Or if they given 40 kilometers in meter per second format, you can easily found it out, because if you change this 40 kilometer into meter per second, you will get I think maybe 11.1 meter per second, I guess. You'll get like 11.1. It will go in decimal only. Okay, it will go in decimal format, so you don't have to do that. You need an approximate answer. So what will happen, this is 11.1, so after that you will calculate, you will find out this, you will convert this kilometer per hour in meter per second. Okay, then you will do all the things. Okay, So that takes a lot of time. Okay, that takes a lot of time. So the thing is, mm, we can solve this in simple mathematics. That is, you have heard of ratio and proportions, right? Ratio and proportions. Okay. So as you know, the comparison here between is um between the distance. They're asking if the same car is moving with 80, okay, what is the minimum stopping distance? Okay. So here for first car, it is, I'm asking the first car. The first car, u is equal to 40, okay, and the second car, u is equal to, let's say this is u1 and this is u2, is equal to 80. And here the distance, let's say s1 is equal to 2. Here s2 is equal to, we don't know that. Okay. So as you know, the acceleration is same. Okay, the acceleration is same for both the situation. For both the cars, the acceleration, that is the retardation, is same. Sorry, the retardation or the acceleration is same. Okay. So what you can do, you can solve this through proportions. That is s2 to the ratio of s1. S2 is proportional to, we can say S2 is proportional to S1, right? Or we can say S1 is proportional to S2. Okay. So we can equate this in such as like this, S1, sorry, S2 is
Sir, is
to,
the answer 4 meter?
is the answer 4 meter is your good name, ma? Your good name?
Disha, sir.
Disha, okay. It's a good guess actually. How did you guess?
Sir, I like
Yeah.
just as you told in ratios. So,
Yeah, in ratios, if you do that, if S2 is to S1, you know this, no? In ratios, if S2 is to S1, we can write as S2 by S1. Am I right or not, Jisha? Yes?
sir,
If S2 is in the ratio of S1, we can write in this format also, no? S2 by S1. Hello?
Sir, I think option A 8 meters, sir.
Very good. So that is 8 meters the right answer. Okay. It's Jayashri.
Yes, sir.
Okay. So we can, others just, listen to this. S2 is to S1 is the ratio. Okay. So when they are in this format, we can write as S2 by S1. So what is S2? S2 is nothing but U2T plus half AT squared, right? Divided by S1 is nothing but U1T plus half AT squared. Okay. Okay. So I said this acceleration is equal. So this is going to be done. And time is also equal. That is also going to be done. Okay. So when we equate S2 by S1 is equal to what? U2 by U1. What is U2? U2 is what? 80 kilometer per hour. So S2 is nothing but 80. S1 is what? 4, right? 40, right? So this becomes, and this becomes 1 and 2. Okay. And yeah, actually I'm doing it in the wrong way, I guess. Am I wrong in any step, Jayashri? Yes. Okay. So am I wrong in any
sir,
step? Yeah.
in addition, how can you cancel that half 80 square?
No, I think I've got this formula wrong. Just a moment. Yes, actually, here, okay, for same retarding force, actually I said that this has the same retarding force, that this acceleration is equal to this acceleration, right? Sorry, this retardation. So there is the same retarding force. Okay, so there is same retarding force. So when there is same retarding force, okay, from there is same retarding force, we can write like this. If S2 is equal to, yeah, yeah, for same retarding force, no, that the distance is proportional to u squared. That is the initial velocity squared. Okay, the distance is proportional to the u squared, that is the initial velocity squared. Okay, so when we equate, that is S2 is to S1. Okay, so what happens is S2 divided by S1 is equal to u2 squared divided by u1 squared. Okay, so for same retarding force, you have to remember this, that there is a same retarding force for this two. For this car also, it is a same negative acceleration, and for this car is also there is same negative acceleration. Okay, so in that, it corresponds to the distance. Okay, the distance is proportional to the initial velocity. Okay, the distance is proportional to initial velocity. Okay, so you can ask me how this has come. So it is, you know the formula, no? V squared minus u squared is equal to 2as. Okay, so now to find out a, v squared minus u squared divided by 2s is equal to a. So here final velocity is equal to 0. Okay, so this becomes minus u squared by 2s is equal to a. Okay, so this is the acceleration. So you understand this? So we are getting acceleration. Yeah.
Yes, sir.
Okay, so we have found out a value of acceleration. Okay, that is u is nothing but u1 squared. Yeah. So now we know that for the same retarding force, that is the same retarding force for the both the, you know, for both the cars actually. So it will correspond to, okay, it will correspond to, yeah. So what is retardation? It is minus a, right? Negative acceleration only, no? Retardation. It is minus a. So here we have acceleration. So what is the retardation? Anyone? So what is retardation? You know a. So what is minus a? Minus a is equal to u squared by 2s. So you understand this? Till now you understand? Disha and others. See, they are given two situations. Okay, here and here. So you know u, okay, and you know v. V is equal to 0. Okay, and yes, you know as 2 meters. Okay, so now what they have said, that there is this, for this car is also the same retardation, and for this car also same retardation. Okay, so you have to find out the value of acceleration. So to find out the value of acceleration, I'm saying v squared minus u squared for the first car, okay, is equal to 2as. So now v squared minus u squared by 2s is equal to a. 2s is going to the denominator. So v, for the final velocity is 0, so it becomes minus u squared by 2s is equal to a. Okay, this is acceleration. But we need retardation because we are applying brakes, right? So what is retardation? Retardation is equal to minus a. So retardation is equal to what? Retardation is equal to minus a, no? So that is u squared by 2s. Positive, u squared by 2s. Okay. So as I said, this distance and distance using proportions, okay, using proportions, I can say as S2 is to S1. Distance of the second motion is to distance of the first motion. Okay. And yes, so for this, okay, so for this, the acceleration involved in the second, okay, in the second one, and the acceleration involved in the first one. Okay, so I'm equating that. So when I do that, that is S2 by S1. Okay, so when I do that, S2 by S1, okay, it becomes this U squared. I'm taking the U squared only. Okay, because we are going to equate the distance. Okay, so that becomes, this becomes U2 squared actually. U2 squared divided by U1 squared. So what is U2 squared? U2 squared is what? This is U2, no? 80 squared divided by 40 squared. Okay, 80 squared divided by 40 squared. So when you equate this, it becomes like S2 by S1 is equal to 4. So this goes here. So S2 is equal to 4 into S1. And S1 is 2 meter. So S2 is equal to 4 into 2. So S2 is equal to 8 meters. So 8 meters is the correct answer. Okay. So you're getting this?
Yes, sir.
What we have said, that is S is proportional to what? For same retarding force, S is proportional to this U squared. So that's what we are equating here. Okay. So when I do proportionality, that is S2 is to S1. So S2, for S2, the initial velocity is U2 squared. Okay, that is here. The retardation, I'm taking the initial velocity alone. Okay, I'm not taking the distance. Okay, because distance is what we are equating. Okay, so distance is what we are equating. So if I, for the same retarding force, if I write like this, U squared, that is U2 squared by 2S2 divided by, and U2, that is U1 squared by 2S1. This S1 and S2, we are equating it as same. Okay, so this value will not be there, so that it becomes U2 squared divided by U1 squared. Okay, so that's how we calculate. So you understand the sum, or do you have any doubts?
Understood, sir.
Okay. So yes, so we'll go to an NCERT problem. This is an NCERT problem. So this is as simple as that. I'll tell you the idea, you can solve and tell me the answer. A car is moving in a straight highway with speed 126 km per hour. So this is U. Initial velocity is brought to a stop with a distance of 200 meter, like the first one. Okay. So distance is equal to 200 meter and initial velocity is equal to 126 km per hour. So what is the retardation of the car? That is in a negative acceleration, retardation of the car. How long does it take to stop? So as you know, it is brought to a stop. So that means V is equal to 0. Final velocity is equal to 0. So can you find this now? So as you know that it is in kilometer per hour. So you have to change into meter per second. So 126 into 5 by 18. So this will go, so this becomes, it will come 35 meter per second. So U is equal to 35 meter per second. Okay. So now you have to find out the value of A and how long does it take for the car to stop. That is, how long means the time taken, T value. Okay, T value. If you want to find out time, you can straight away, you can write like this, 35, that is S is equal to U plus V by 2 into T. U is equal to, that is 35 plus 0 by 2 into T. But I don't think this is this will yield it. This will yield the correct answer only, but it will comes in decimal format. Okay, it is not a whole number, so it becomes like S is equal to I think 17.5, right? 17.5 into T. S is equal to 200 is equal to 17.5 into T. So you don't have to do this. Okay, so don't do this. You do the traditional one. Traditional one is what? First you find out the acceleration. So how do you find out the acceleration? V squared is equal to U squared minus 2as. Here we are finding out the retardation. Okay, V squared is equal to U squared minus 2as. So find the retardation value, then employ it in the first equation, that is v is equal to U plus, that is V U minus AT. Okay, so in that you employ in that. Okay, now you can find out the answer, then you can find out the value of time. So after you find this problem, we'll finish off this class. Okay.
Sir,
Yeah.
sir, acceleration equal to minus 3.
Excuse me, you're not audible, ma. Sorry.
Acceleration is equal to minus 3.06.
Acceleration is equal to minus 3.06 meter per second squared. Very good. This is the right answer. The question they're asking retardation. So the retardation is equal to what? Minus of acceleration. So it becomes 3.06 meter per second squared. Very good. This is the right answer. So what about T? T value is equal to?
So 11.43 seconds. Sir.
Very good. 11 point time is equal to 11.43 seconds. Very good. So this is okay. Very good. Okay. So next we have another question. Okay, this is the final question in the uniform acceleration part. So as of now, we have completed, I think, 95% of the uniform acceleration part. So tomorrow we'll solve this question and we'll move on to relative velocity first. Okay, we go to relative velocity, or we'll go to motion under gravity. Okay, motion under gravity, and we have distance traveled in nth second. So these three topics if finished means you have completed the motion in one dimension chapter. Okay, so you'll probably have a test. Okay, it will be uploaded. We will, after completing these three topics, you'll have a test uploaded. In that we'll inform you, and after that we'll start with motion in a plane. Okay, motion in 2 dimension or motion in a plane. Okay. Okay, right. So thank you, students. If you have any doubts, please let me know. Okay, so or else, so we are done for today. So we'll meet in tomorrow's class. Okay, so if you have any doubts, please let me know, or else we can wind up with this class. So we have Disha, Jayashri, Mrinalini and Soumya. So if you have any doubts, you can let me know right now. Okay, ma. So yeah, for NEET and class 12 students, they have a class at 7 p.m. You may as well attend that class. Okay, so you can leave the class now.
Thank you.
Thank you, sir.
Thank you, Jayashri, Soumya. Thank you, Mrinalini. Thank you.
Thank you, sir.
Disha, thank you. Thank you. Yes.